This is for Year 11 methods. We're going to look at question 6 from the chapter review. So I'm trying to solve this equation. Sine of theta equals negative root 3 on 2. Theta is between negative pi and pi. So first things first, whenever we're trying to solve two equations, we're trying to find the base angle. The base angle is given by inverse sine of root 3 over 2. So the angle gives me a value of root 3 over 2 for sine from our exact values table is pi over 3. Okay, so that's our basic angle. Pi over 3 sits here in the first quadrant. That's my theta. In the second quadrant, we have pi minus theta. Third quadrant, pi plus theta. And in the fourth quadrant, 2 pi minus theta. So that's my all students take chocolate. I know sine is positive in the, not positive, negative, because we got a negative value here, in the third and fourth quadrants. So theta would equal, my two solutions would lie in the third quadrant, which is pi plus theta, which is pi plus pi over 3, which is 4 pi over 3, and 2 pi minus pi over 3, which is 5 pi over 3. So my two solutions are 4 pi over 3 and 5 pi over 3. These are two of my base solutions, okay? They're not necessarily our final solutions. Remember how from our two solutions you can get more solutions by adding or subtracting 2 pi? Now, these two solutions aren't what we want, but we can get the solutions we want by subtracting pi, because these are over already. These are over pi, which is not what we want. So if I subtract 2 pi from that, I get negative pi over 3. If I subtract 2 pi from that, I get negative 2 pi over 3. Okay, can you see these two solutions are within the domain of negative pi to pi? Okay, so that's what we want. So those two solutions will be our answer. So that's not what we want. Okay, for B, you got to be careful. Whenever we have 2 theta, we got to double our domain, because theta is between negative pi and pi. So if we're solving for 2 theta, we're going to make sure our domain is from negative 2 pi to 2 pi. So what I'm doing is I'm doing something similar. I'm going inverse sine. I'm trying to find the base angle. Inverse sine root 3 on 2. So the angle that gives me root 3 on 2 for sine is pi over 3. I'm going to go all students take chocolate. My base angle is pi over 3 in the first quadrant, but we want a negative sign. So we got here and here. So it's 4 pi over 3 in the third quadrant and 5 pi over 3 in the fourth quadrant. Fourth quadrant. So my solutions for 2 theta, because we're just solving for the angle, which is 2 theta, equals 4 pi on 3 and 5 pi on 3. Okay, and we're solving, remember 2 theta is solved between negative 2 theta and 2 theta, negative 2 pi and pi, 2 pi. So we've got to make sure we get all our solutions. Now, that's one revolution. If I go one revolution around the circle, I pick up these two solutions. If I go backwards, I need to subtract 2 pi from these two solutions. So I get negative pi on 3. So if I subtract 2 pi from 5 pi on 3, I get negative pi on 3. If I subtract 4 pi on 3, 2 pi from 4 pi on 3, I get negative 2 pi on 3. Okay, which makes sense. So what I'm doing now is dividing both sides by 2 to get my final solution. So 4 and 3 divided by 2 is 4 over 6. 4 over 6 is 2 pi over 3. 5 pi over 3 divided by 2 is 5 pi over 6. Should be negative pi over 6. Should be negative pi over 3. Okay, so all I'm doing is just solving for first 2 theta and then dividing all the solutions by theta. Okay, so hopefully that gives you an idea of how to solve question 6.